Welcome dear learners. We are continuing Unit 5 Inorganic Chemistry Practicals 1 Volumetric Analysis. In the present module, we are discussing experiment number 2, that is strong acid versus weak base titration. As a selective example, we are taking hydrochloric acid against sodium carbonate as an example. The contents of this module are mention about acidimetry and alkalimetry, hydrochloric acid against sodium carbonate titrations, indicator selection, reagents required for the experiment, procedure, demonstration of the experiment, calculations and final results. First of all, acidimetry and alkalimetry. You are very much familiar about volumetric analysis and titrations involving acids and alkalis. The titrations or volumetric reactions involving acids and alkalis are generally known as acidimetry and alkalimetry. This about the clear-cut definition of acidimetry and alkalimetry. Acidimetry and alkalimetry refers to titrations involving acids and bases in volumetric analysis. Acidimetry is the quantitative analysis of a basic or alkaline substance using standard acid solution. That means in acidimetry, we have to estimate a basic solution or alkaline solution using a standard acid solution. Alkalimetry is just opposite to that of acidimetry. In alkalimetry, the quantitative analysis of an acidic substance is performed by using a standard base solution. That is, in alkalimetry, we are estimating acidic solution using a standard solution of a base. The basic principle of acidimetry and alkalimetry is nothing but neutralization. Neutralization, you are familiar. It is the reaction between an acid and a base to form a salt and a solvent or water. Then equivalence point in titrations or equivalence point in acidimetry and alkalimetry. The point at which the amount of acid equals the amount of base in the reaction is referred as the equivalence point. Equivalence point is highly theoretical. It is not possible to exactly determine the value of the equivalent point or equivalence point. However, it is possible to find out or evaluate the end point of a reaction. Then what is meant by end point? The point at which the indicator changes its color, signaling the completion of the reaction is known as the end point. For example, in acidimetry and alkalimetry or in acid-base titrations, you can use phenolphthalein as an indicator. In basic medium, phenolphthalein is pink in color. However, when that pink color changes to a colorless solution, you can say that the reaction reached the end point. That is, whenever you switch from the alkaline medium or basic solution to just acidic solution, the color of the indicator changes. So, the color change of the indicator is a clear-cut indication of the end point. End point is not at all equivalent to the equivalence point. There occurs some difference. Equivalence point is quite theoretical, but the end point can be determined by using experiments. Now we are coming to the present experiment, experiment number 2, that is nothing but the titration between hydrochloric acid and sodium carbonate. That is, we are discussing HCl against sodium carbonate titration. Hydrochloric acid abbreviated as HCl and sodium carbonate abbreviated as Na2CO3 titration is a strong acid against weak base titration. It is clear that sodium carbonate is a weak base. At the same time, hydrochloric acid is a strong acid. The double burette method that we discussed in the case of the first experiment is also used in the present experiment. That is, we are discussing the double burette method of titration between hydrochloric acid and sodium carbonate. Aim of the present experiment is shown here. The aim is to estimate the weight per liter of the given hydrochloric acid solution. and you are provided with annular sodium carbonate crystals. So, you are having an unknown solution of hydrochloric acid with you and a standard and annular sodium carbonate crystals are with you. By using the AR sodium carbonate crystals, it is possible to create a standard solution of the sodium carbonate because sodium carbonate is a primary standard and you can weigh out accurately the sodium carbonate and make up a standard solution using the weighed sodium carbonate. So, we are discussing the titration between hydrochloric acid and sodium carbonate. The principle of this titration is shown here. Hydrochloric acid reacts with the sodium carbonate as per this balanced chemical equation. Sodium carbonate plus 2 molecules of HCl gives 2 NaCl plus carbon dioxide plus water. This is a clear-cut example for a neutralization reaction. According to this reaction, it is clear that 1 molecule of sodium carbonate reacts with 2 molecules or equivalents of hydrochloric acid. Therefore, the equivalent mass of sodium carbonate must be molecular weight divided by 2. It is clear that the equivalent weight of sodium carbonate equal to 106, that is molar mass or molecular weight of sodium carbonate divided by 2, and equivalent weight is equal to 53. For the estimation of hydrochloric acid, a standard n/10 solution of sodium carbonate has to be prepared and titrated with the given HCl. The unknown concentration can be calculated using the formula NHCl into VHCl equal to N sodium carbonate into V sodium carbonate. Here, NHCl represents normality of the hydrochloric acid solution. VHCl represents volume of HCl. N Na2CO3 indicates the normality of sodium carbonate solution that you prepared, and V Na2CO3 is the volume of Na2CO3 that is used to neutralize the given volume or the taken volume of unknown hydrochloric acid. Now, indicator selection. We are dealing with acid-base titration, especially we are considering a strong acid versus weak base titration. Therefore, selection of the indicator is of prime importance. Common acid-base indicators are here. Methyl orange and phenolphthalein are two popularly or commonly used indicators in acid-base titration. This is a chart which represents the pH range as well as color change of these two indicators. Methyl orange has a pH range of 3.1 to 4.4 and the color change of the methyl orange indicator is from yellow to red. That is, the methyl orange is yellow in base medium whereas red in acid medium. Phenolphthalein has a pH range of 8.3 to 10. It is clear that the indicator phenolphthalein is pink in basic medium whereas it is colorless in acid medium. So, the color change is from pink to colorless at the end point. This is the case of the phenolphthalein indicator. Now, indicator selection. This is a chart that leads you to select the appropriate indicator. The first column represents titration type, second column represents the indicator that can be used, and the final column represents the pH range at the end point. First of all, strong acid against strong base titration. From the chart, it is very well clear that you can take either phenolphthalein or methyl orange, or both indicators are useful for strong acid versus strong base titration. And for such a titration, the end point is nearly 7, that is neutral. However, you take the second titration type, that is strong acid against weak base titration. The apt indicator based on the pH range is methyl orange, and the pH value near the end point or at the end point is less than 7 or acidic pH, and the color change is from yellow to orange red. Yellow in basic medium, orange red in acid medium. And the last type of titration, that is weak acid against a strong base. The most appropriate indicator for such a titration is phenolphthalein, and the color change is from pink to colorless, pink in basic medium and colorless in acidic medium, and near the end point the pH is greater than 7, that is the pH is basic. Thus from the chart it is clear that for the present experiment, that is a strong acid against weak base titration, we select methyl orange as the indicator. So in the present experiment, that is the titration, the volumetric analysis between or titration between strong acid and weak base, we select methyl orange as the indicator. You have to remember the fact that the color change is from yellow to orange red or yellow to red. Methyl orange is yellow in basic medium, whereas it is red in acid medium. Now, reagents are required for the present experiments. We are discussing the titration between strong acid HCl and weak base sodium carbonate. These are the reagents required. Number 1, annular sodium carbonate crystals, and this is required to prepare a standard n by 10 solution. You have to weigh fixed quantity of sodium carbonate and make up the substance to decide volume to get n by 10 solution. Approximately n by 10 hydrochloric acid solution. This is the solution which is used for estimation. That means this is the solution whose concentration has to be estimated. Number 3, methyl orange indicator. We select methyl orange as the indicator for the present experiment. Now, experimental procedure. We have to discuss the experimental procedure first, and then we can demonstrate the present experiment. This is about the experimental procedure. First of all, we have to prepare a standard n by 10 sodium carbonate solution. That is, we are discussing the procedure for the preparation of standard n by 10 sodium carbonate. Mass of Na2CO3 required to prepare 250 ml of n by 10 solution can be calculated by using the expression weight required equal to VEN divided by 1000, where V represents volume of the solution in ml, N represents normality, and E represents the equivalent weight. On proper substitution, you are getting the weight required will be equal to 1.325 gram. Remember, we are fixing the volume of sodium carbonate is 250 ml and the normality is fixed as n by 10. So, the weight required is 1.325 gram. Now, in order to prepare a standard solution of n by 10 Na2CO3, roughly weigh 1.325 gram of Na2CO3 and transferred it into a dry weighing bottle. It is then weighed accurately in an electronic balance and the weight is reported or recorded as W1. The substance is now transferred into a 250 ml standard flask through a funnel and make up to the mark. The weight of the empty weighing bottle is now taken and recorded as W2. Now, the actual weight of sodium carbonate taken equal to W1 minus W2, that is the difference in weight. Empty bottle weight is W2, bottle plus substance weight is W1. So, the difference W1 minus W2 will give the exact weight of sodium carbonate that is transferred to the standard flask. This weight W1 minus W2 is used to find out the concentration of the sodium carbonate solution as normality equal to weight per liter divided by equivalent weight. Now, in order to start the titration part, we are adopting, as I just mentioned, the double burette method for titration. For this, set 2 burettes, one with the hydrochloric acid and other with the sodium carbonate. 16 ml of sodium carbonate is now added into the conical flask. 1 drop of methyl orange indicator is added. It is then titrated against hydrochloric acid and end point is determined. Remember, the end point is the color change from yellow to orange red. Now, from the titer value, we can calculate the normality of the unknown hydrochloric acid using the relation NHCl into VHCl equal to NNA2CO3 into VNA2CO3. To this solution left in the conical flask, 2 more ml of sodium carbonate is added from the other burette. It is again titrated against HCl. and determine the end point and also calculate the normality. Now, the process is repeated with 20 ml, 22 ml and 24 ml of sodium carbonate, and normality is calculated in each step by using the expression as we used in the case of the previous calculation. Average of all these values of normality is taken as the normality of the unknown HCl solution. Graphical method can also be used to adopt to determine the unknown concentration. Now, demonstration of the present experiment. So, we learned about the theoretical aspects of the experiment, the steps of the experiment, and now we can demonstrate the titration of HCl against sodium carbonate in the laboratory. Now, we are discussing we are now demonstrating the tubular method of titration between a strong acid and a weak base. For the sake of convenience, we select hydrochloric acid as the strong base and sodium carbonate as the weak base. And the first burette is filled with hydrochloric acid and the second burette is filled with the sodium carbonate. Regarding the experiment, we have to drop out 16 ml of sodium carbonate from burette 2 into a conical flask. Add 1 drop of methyl orange indicator and titrate against hydrochloric acid taken in burette 1. Again add 2 more ml of sodium carbonate and repeat the same process. And the entire process is repeated by adding 2 ml of sodium carbonate in each titration up to a total volume of 24 ml. In each case, we have to record the titer value of hydrochloric acid. We can calculate the normality of the solution from the formula N1V1 equal to N2V2. You can also calculate the final value of normality of the unknown solution by graphical method.
Now we are taking 16 ml of sodium carbonate from the burette 2 and the solution is drained carefully into a conical flask. Now we took 16 ml of sodium carbonate solution which we prepared into the conical flask. Now the methyl orange indicator is adding. you can see the formation of an yellow color during the addition of the methyl orange indicator. The solution is now shaking well and it is titrated against hydrochloric acid solution taken in the other pipette. The end point of the titration is the color change from yellow to orange red. The reaction is now nearing to the end point and now the end point is reached. This is indicated by the formation of orange-red color. The reaction is now completed. Now you have to take the burette out, note the titer values and record that titer value in your notebook. And you can repeat the titration by adding 2 more ml of sodium carbonate. This process is repeated up to a total volume of 24 ml of sodium carbonate.
Now, we have completed the experimental demonstration part or experiment demonstration part, and now we are going to adopt the values that we got during the experiment, or we are now entering into the calculation part and finding out the results. The weight of sodium carbonate taken is equal to W1 minus W2, where W1 is the weight of weighing bottle plus sodium carbonate. W2 is the weight of empty weighing bottle. So the difference W1 minus W2 will give the weight of sodium carbonate taken. And in the present experiment, the difference W1 minus W2 will be equal to 1.342 gram. So, weight of sodium carbonate per liter is equal to 1.342 multiplied with 4. Then you may have a doubt, why multiply with 4? Remember, the weight 1.342 gram is transferred into 250 ml standard flask. So, 1.342 gram is the weight of per 250 ml. 1 liter is 1000 ml. So, to get the weight per liter, you have to multiply with 4. So, weight of sodium carbonate per liter of the solution will be equal to 5.368 gram. In order to get to the normality, you have to divide weight per liter with the equivalent weight. So, 5.368 divided by equivalent weight of sodium carbonate, that is equal to 53. You got the value as 0.1013 normal. So, this is the normality of the standard Na2CO3 solution. So, you prepared standard sodium carbonate solution. Its normality is calculated as 0.1013 normal. Now, the titer values, that is the values we got during the double titration between HCl and sodium carbonate, can be tabulated like this. Volume of sodium carbonate 16, 18, 20, 22, 24. Volume of HCl, that is the end point of the reaction. Corresponding end points are 16.2, 18.3, 20.4, 22.4 and 24.3. It is also possible to calculate the normality, and normality is calculated and tabulated in the last column. And normality is calculated by using, normality of HCl is calculated by using this expression NHCl equal to Na2CO3 multiplied with V Na2CO3, and the quantity should be divided with VHCl. So, we got titer values, we got volume of sodium carbonate, and we got normality in 5 different cases. And the normality of HCl solution is the average of all these 5 values. So, you can find out the average value of normality as 0.1001 plus 0.0996 plus 0.0993 plus 0.0995 plus 0.1001 divided by 5. You are getting the average value of the normality of HCl solution, or unknown HCl solution has a normality of 0.0997 normal. Weight per liter of given HCl can be calculated by using the expression weight per liter equal to normality into equivalent weight. So, you have to multiply this normality 0.0997 into equivalent weight of HCl, that is 36.5, and the result will be equal to 3.639 gram per liter. Graphical method can also be used to find out the normality of HCl. For this purpose, you have to plot a graph by taking volume of HCl in the y-axis against volume of sodium carbonate in the x-axis. Definitely graph will be a straight line and you can calculate the slope from the graph itself. So, normality of HCl can be calculated by using the expression normality of HCl equal to normality of sodium carbonate divided by slope of the curve. So, you can also calculate normality from graphical method also. Now, the final results are shown here. The normality of the given HCl solution is calculated as 0.0997 normal, and finally, the weight per liter of given HCl solution is equal to 3.639 gram per liter. Thus, we have discussed and demonstrated the titration between strong acid hydrochloric acid HCl against weak base sodium carbonate or Na2CO3. That's all about the present module. Have a nice learning experience. Thank you.